Now, so far, everything I've said has been scientifically wonderful, but not of great practical use. The really exciting thing about this Nobel Prize and the work that's been done by these three scientists is that they can understand how antibiotics, the drugs people take that kill bacteria, how they operate, because these antibiotics interfere with the reading mechanism so that either it stops reading or it starts making mistakes. So the wrong proteins come out and the bacteria die. But because bacteria evolve so quickly, they multiply very quickly, bacteria will reproduce in less than an hour, so they can reproduce very many generations. They can quickly develop resistance, and the basis of the resistance is by making sure that the reading mechanism can avoid being interfered with by a particular antibiotic. And so the work that's been done and the understanding of the structure of the ribosome has led to the much better ideas how we can make new antibiotics that will avoid bacteria getting resistance to them. Because, of course, once the bacteria are resistant, you can take as much of the antibiotic as you like, and you'll still be ill. And it's really important to remember that it was only 2 or 3 years before I was born that penicillin was actually starting to treat people, and for the first time in human history we could cure bacterial infections. People who are not much older than me used to die from insect bites, from scratching themselves while gardening. And now, at least in developed countries, such things are almost something of the past. But using this new science, we will be able to continue to develop antibiotics so that we can keep ahead of the bacteria and make sure that we can continue to cure them for future generations.
Good.
Okay.
So you're quite excited by this one then?
Yes.
You quite enjoyed it?
I'm very excited by this, and I'm particularly excited because it was one of the prizes, Ramakrishnan's, or 1/3 of the prize, was won by the Laboratory of Molecular Biology in Cambridge. This laboratory was founded in about the year I was born, so about 60 odd years ago, by the very famous scientist Max Perutz, who I knew quite well. And his laboratory that he founded has won, I can't remember now the number, whether it's 13, 14 or 15 Nobel Prizes. This one laboratory has won prizes for the structure of DNA, for the structure of hemoglobin, and many other prizes. So it is really wonderful that yet again they have been recognized for their pioneering work. And much of what we know about how life operates has come from this single laboratory. So, as the machine works, you turn the crystal round so that you can get different planes of the crystal will diffract the light, and so you get more information to get a three-dimensional structure. So the machine turns the crystal round to different positions and then moves the camera as well. So you get a really quite complicated pattern with thousands of spots.
Does the professor know how to use this machine, or is he pretending?
I think he could use it if he wanted to. Just a little bit of training.
Yeah.
A little bit.
Yeah.
I'm being kind.
Yeah, you are.
No, so I'm pleased that Charles Cowers won a share of the prize. I don't know him personally, but I in the early stages of my career, I knew the lab in which he worked, STL in Harlow. So there's very definitely a British connection for half the prize. So that's good news. And I note that the other two people are from Bell Labs. And there's some sadness as well, reflecting on what's happened to both Bell Labs in New Jersey and STL in Harlow, that these labs in the 1970s and 80s, even going up towards the 90s, were, well, certainly in the case of Bell Labs, were doing absolutely outstanding world-class research. But fundamental research has almost died out. I mean, STL has been sold off and split up, and goodness knows what's happened to it. I think it's now recently been last year bought out. What was it has been bought out by a couple of companies. And I was just looking at an article when the prize was awarded today. I just saw this thing from Nature last year, Bell Bottoms Out, which says that Murray Hill has just got 4 people working on fundamental research. And so one can perhaps think of, well, what it's going to be like 20 years down the line. The only way in which Western countries are likely to win Nobel Prizes is from university labs, because fundamental research seems to have died out there. But of course, if you look to the Far East, Japan already, and then China and India, perhaps more so in the future, maybe Singapore and Korea, probably industrially funded research, there the Nobel Prizes are quite likely to be won there, because of the demise of high-tech industries. Just don't seem to do very much fundamental research in the UK and the US. Well, I think companies are motivated by profit. Profit is short term. We've heard about the decline of the banks. Chief executives have got to make profits for their shareholders, for investment companies, and so on. And I think Western industrial research has just lost this long-term view. Poor, Bell would be turning in his grave if he saw this, that you have to have a 20-year horizon in order for the developments of fundamental research to find their way into applications. And politicians and industrialists should remember that. And I think we've forgotten that lesson, or lost that idea in the West, even though all of this great science was initiated in the West.
So today's Nobel Prize in Physics, that was all private stuff, was it? I don't think we've quite made that point.
Well, it was done in industrial labs, yes, rather than in universities. I mean, these companies, of course, have always traditionally had close links with universities, and some of the scientists who won the Nobel Prize for the fractional quantum Hall effect, that involved a combination of university research done at Princeton and at Bell Labs.